Hello everyone, welcome to our channel. Welcome aboard a journey to the vast field of AI and machine learning where we learn while also having some fun. We are going to start with the concept of regression, in which we will go through linear and polynomial regression. To recap, we will talk about dataset. A dataset is a collection of data samples, all of which have some similarity, some likeness with one another. The datasets usually have properties called features, which help us find the patterns and predict the other features. Now, the datasets can be of two types: training dataset and test dataset. So, the training dataset has something called as features, which are known, and a target value, which is also known. So, with these values, we train a model. The test dataset is a different kind of dataset where only the features are known to me, but the target is not known. But suppose you want to check how good my model is performing. So you have the test set and you also have the target values. So you took my model that I provided you that was trained on the training dataset. You took that trained model and you predicted the target values by providing the known features as input. Now you got a set of predicted values which you will compare with the target that you know, and after comparing you will get some error, and based on that error you will be able to understand how good my model is that I provided to you. So, the test set is used for testing the accuracy or the goodness of the model that has been trained using the training dataset. Machine learning models help us predict the target values of data samples in the test set using the patterns learned from the data samples in the training set. Regression. Regression is a statistical model designed to find patterns in a dataset. Through regression, we aim to predict some target feature or label of a data sample in the test dataset using the pattern that relates the training features and the label in the data. In order to do so, we try to fit a line that can be either straight or curved that is closest to all the data points. The regression line is a continuous function in the range of the label or the target where the data set, whether the training or the testing data set, is a set of discrete points where the y coordinate or the value of each point is the label of that point. So, the training data set, the data set on which we are training, is a discrete set of data points, whereas the model that we will train will be a continuous function or a continuous line here. Now, the regression function f fitted on the training dataset x in approximates the labels y dash. So, the regression function here f of x in stands for training data samples. So, the regression line here is the function f. The regression function f trained on the training dataset x in will approximate the actual value y dash. So, what do we want to do? We want to minimize that error in the approximation. What is the error? The error is the squared difference between the output of the regression function and the actual label of the data point. That is the individual error in the training data set. When we add all the individual errors in the training data set, we get the total error or the combined error in the training data set. We want to minimize this combined error. Next, we can talk about some of the areas of application. So, first, we have housing dataset where we can predict the price of a house given various values or various features, like whether it is close to a school or college, whether it is in a high latitude or in a low latitude. Many things will matter, right? To predict the daily temperature, what you need? You need the precipitation, humidity, wind speed, and daily temperature for a few days. And then you will try to figure out what the next day's temperature can be. Another example is stock price prediction. These are some of the areas in which regression can be applied. Then we have a real life dataset, the real estate dataset. So the real estate dataset has transaction date, the date when the real estate was bought or sold. So what is the age of the house that is being sold? What is the distance to the nearest metro station? So obviously if the metro station is nearby, the price will be high, and then if the number of convenience stores is greater, the price will be higher. The lower number of convenience stores means the price will be lower. Again, latitude matters. High latitude, probably in Europe or America, the price will be high. If it is lower latitude, it will be in the tropical countries, the price will be low. And longitude, that also matters similarly. And then house price per unit area, that is the one we are trying to predict. This is the target value that we are trying to predict. So what do we want to do? We want to see how one feature relates to the target value. So let us see how the distance to the nearest metro station relates to the housing price per unit area. So to do that, we need to sort the feature values according to the target value. The distance to the nearest metro station should be in ascending order. You can check that they are all in ascending order. And how did we do that? By using data frame dot sort values, where in the columns by we have to provide the name of the column. Here we are providing the axis. Zero axis means we are sorting in the row axis or the zeroth axis. And in place means the CS, same CSV will change, no new CSV will be created. Ignore index means the original indices will be forgotten and new indices will be created. Now we want to see the pattern between the sorted distance to the nearest metro station and the corresponding housing price. You can already see that there is some kind of negative correlation. Let us see the plot. So in the plot also we can see a negative correlation between the distance to the nearest metro station and the housing price. How we have created this plot? We have created this plot by using matplotlib.pyplot.scatter. We use scatter, in which in x we provide the distance to the nearest metro station, in y we provide the house price per unit. So negative correlation, distance to the nearest metro station is increasing, the price is decreasing. So we can plot a line to approximate this correlation, which is the regression line.